Next problem deals with this. Evaluate, everybody take down this. Evaluate the following convolution sum. Evaluate the following convolution sum. And they have given that convolution sum to be y of n. Okay, and this is beta power n u of n convolution u of n minus 3. So this is how the convolution sum is. So this we need to what? Look at. Maybe this is problem number 5 for you. Now let's consider this x1 of n as this beta power n u of n. That means the first signal here, let it be x1 of n, and let the second signal be x2 of n. You can call it as x of n and h of n also, not a problem. So let's consider this. Fine. Now let's have y of n. Therefore, y of n can be given as x1 of n convolution sum x2 of n. Okay, and this is given as summation k ranging from minus infinity to infinity x1 of k. The first signal x1 of n should become x1 of k, and the second signal should become x2 of n minus k. So this is what is the equation. Fine. So this is, now we need to bring in these x1 of n and x2 of n in this place. But this x1 of n would be represented as x1 of k. That means in place of n, I need to replace that. I need to bring in k. Okay. Similarly here, in place of n, I need to bring n minus k. Understand that? So that we need to do now. So let's go on. Therefore, y of n would now look like summation k ranging from minus infinity to infinity beta power k into u of k. This is the first signal, and the second signal would come as x2 of n minus k, right? So it is u of n minus k minus 3. Fine. So where there is n, we have substituted that n as n minus k. It's just that. Fine. So till now in all the problems, we have dealt with something like u of n minus k as the second signal. Okay. So let's bring in this also in this particular form. In place of n, let's write n minus 3. Okay. So this would now be written as what? K ranging from minus infinity to infinity beta power k u of k. So let's write this as u of n minus 3 minus k. Fine. Now, what is that you've understood regarding u of n minus k? What is u of n minus k? See here, everybody. U of n minus k is here. Let me just show you this. Yeah. So u of n minus k is a signal which ranges from minus infinity to n. If u of n minus k ranges from u of minus infinity to n, then what do you think u of n minus 3 minus k ranges from? Anybody? Let me just show you that. See here. This u of n minus k here. Okay, this ranges from minus infinity to n. So which means that u of n minus 3 minus k ranges from minus infinity to n minus 3. Is that understood, everybody? So this is what is tricky about this problem. Till now, we had not got this type of a signal which deals with u of n minus 3 minus k. We had been seeing u of n minus k, but in place of n, we just have n minus 3. If n minus k is shifting u of minus k to the right by n position so that the range becomes minus infinity to n. So this signal is shifting u of minus k to the right by n minus 3. So that means the range would become minus infinity to n minus 3. And what is this beta? I forgot to give you one information here. Everybody, take down this. In this, beta is given to be less than 1. This is very important actually. Okay. So if you don't read that beta is less than 1 in this particular signal, okay, the output will not be able to write. Fine. So this beta is less than 1 in this beta is very important because that is when we understand what type of an exponential this. Can you now tell me if beta is less than 1, okay, what type of an exponential is this? Is it growing exponential or decaying exponential? Anybody? Understand? If it is beta per k, fine, then it looks like this. So it is growing exponential. At 0, we have 1. When beta is greater than 1. Okay. Suppose we have beta per k. So that will look like this. And at 0, you will have 1 when beta is less than 1. That means this beta power k is an exponential. So depending on what beta is, this would be growing or decaying exponential. Since they have told beta is less than 1, so it's a decaying exponential. Now it is decaying exponential ranging from where to where, anybody? If you just take this whole signal into consideration, tell me it is decaying exponential and ranging from where to where? It's ranging from 0 to infinity. Understand that? So this is beta per k, which is decaying exponential, and it ranges only from 0 to infinity. From here onwards, it ranges. There should be no signal here. Understand? So that sketch we need to do now. Fine. So let's just talk about that. So this is decaying exponential ranging from 0 to infinity. Who tells us that is 0 to infinity? U of k tells us it is 0 to infinity. Okay. And this is u of minus k ranging from or u of minus k shifted to n minus 3 to the right. Okay. So it ranges from minus infinity to n minus 3. So let's draw this. Fine. This is stationary. This is stationary signal. And this is moving signal because it has both n and k in it. Understand? So let's everybody just see this. So when it is beta power k, I've been telling you that it ranges from 0 to infinity. So it starts here. What is beta power 0? Let beta be anything. Beta power 0 is 1. When it is 1, okay, beta power 1, when beta is less than 1, is less than this. Okay, so let's not bother about what it is. We understand that it has to be decaying like this. Okay, and it keeps happening. Somewhere it gets 0, okay, but this is what is the signal. This is u of, sorry, beta power k into u of k is this. Fine. Now we need to draw u of n minus 3 minus k. So I've told you u of n minus 3 minus k is u of k ranging from minus infinity to n minus 3. So, so here you have the signal ranging from minus infinity. Okay, so it comes here, then this. Fine, so this is 0, this is minus 1, this is minus 2, this is minus 3, and this is n minus 3. Earlier, we had seen a signal where it used to end at n. Now it is n minus 3. So that is what is tricky about this problem. So this is u of n minus 3 minus k. Fine. Now earlier we used to talk about when n minus 3 comes and stands at 0. When n comes and stands at 0, we used to say. Now we need to refer to this person as standing at n minus 3. So when this n minus 3 becomes 0, then this first player handshakes with this player. When n minus 3 is greater than 0, there are multiple players handshaking with the players over here. Understand? So this is moving signal. This is moving signal. It is moving in this direction. So can you tell me now, in case 1, when would there be a no overlapping case? When there are no players handshaking? Can anybody? When there are no players handshaking?
When n is less than 3.
No, it's not n. That is what I said. It's not n now.
n minus 3 less than 0.
Yeah. First we need to say when n minus 3 is less than 0. So that is this. Let me take different colors because the provision is there now. Okay. So this is the standing signal. It's like this. Let me just draw that in continuous form. And there is this signal. So this is from 0 to infinity. And there is another signal. Okay. Which is this. And say it is somewhere here. Okay. Then it is when it is greater than 0. Why? Fine. Then there will be overlapping. When it is not greater than 0, it looks like this. This is n minus 3. No overlap. See, n minus 3 is less than 0. When n minus 3 is less than 0, there is no overlap. Understand that? So, no overlapping. No overlapping. Right? So when there is no overlapping, y of n would be 0. So y of n. So let me tell you, let me see, this is n minus less than 0, right? So this implies that it is n less than 3, as one of the persons said that. So it is n less than 3 finally, but to begin with, we need to see it as when n minus 3 is less than 0. So when minus 1, when n minus 3 is less than 0, it is as good as saying when n is less than 3 because of this equation. Understand? So y of n is 0 when n is less than 3 is the first case. Understand that? So what is the second case now? Second case now, case 2. Yeah, when n minus 3 is greater than or equal, when it is equal to 0, then also there is overlappings here. When n minus 3 is equal to 0, the first player here will be handshaking with the person at n minus 3. So when n minus 3 is 0, there is overlapping happening. So when n minus 3 is greater than 0, then also the overlapping is happening. So how to show that is in this way. See here, let's again take this, okay, and write this particular signal. This just for your reference. Okay, so let's take this signal which is moving. Fine. And it is going somewhere here. I don't know where it goes and stops. I'm just saying when it is n minus 3 is equal to 0 or greater than 0. Fine. So where is the what? The overlapping happening? Can you tell me the overlapping range? See here? So this is where
0
the
to n minus
overlapping
3.
is happening. Understand that? So when n is greater than or equal to 3, or let's say when n is greater than or equal to 3. This is another way of looking at it. We can say when n minus 3 is greater than or equal to 0, which is as good as saying when n is greater than or equal to 3. So when n is greater than or equal to 3, okay, overlapping range, let's see. There are signals overlapping. So when there are signals overlapping range is 0 to n minus 3. Understand that? Now, when it is 0 to n minus 3, your equation 1 becomes what? Here is your equation 1. Let's call this as equation number 1. Everybody just show this as equation number 1. Okay, this is y of n. So equation number 1 implies what? This beta of power k is beta power k, but this u of k would be 1 and this is also 1. These two are 1, but this would be beta power k. Understand that? So that is what is happening. Fine. So therefore, equation number 1 implies that, okay, y of n would be equal to what? Summation what? N minus, sorry, k ranging from 0 to n minus 3, okay, beta power k into 1 into 1, because u of k is 1, u of n minus 3 minus k is also 1. Understand? So this is how it is going to look like. Now, with the standard summations that I've given you in your previous class, can you tell me what is this going to be? What is this going to be? Anybody? Just write down this. We know that summation k ranging from 0 to n, a par n, is actually equal to 1 minus, it's a par k, sorry, 1 minus a par n plus 1 divided by 1 minus a when a is not equal to 1. So beta is less than 1, they have told. Beta is less than 1 means beta is not equal to 1. Understand? So therefore, I can write my y of n, okay, equal to what? Sorry, why I'm writing that summation? Equal to 1 minus beta to the power. Yeah, beta to the power what now? If it is n, it is n plus 1. If it is n minus 3, it is n minus 3 plus 1. What is n minus 3 plus 1? It is n minus 2. So beta power n minus 2 divided by 1 minus beta. So this is how it looks like. Okay, so when is this happening? So this is happening when n is greater than or equal to 3. Understand that? So this is what is the result of convolution sum when n is greater than or equal to 3. Now we shall summarize this. How to summarize? Okay, summary of the problem, summary of the results rather, what we have done so far. Summary, result summary, it says that your y of n is 0 for n less than 3, and it is 1 minus beta to the power n minus 2 by 1 minus beta for n greater than or equal to 3. So this is one way of writing it. There is another compact form of this. What is that? Anybody? In terms of unit step function, if you have to write it. Anybody? So it is 1 minus beta to the power n minus 2 minus 1 minus beta into what? So this is ranging from where to where? So it is 0 for n less than 3, and it is this for n greater than or equal to 3. So that is the range. So it should range from 3 to infinity. So which is the unit step function which ranges from 3 to infinity? Anybody? Which is unit step function which ranges from 3 to infinity?
U of n minus 3.
Yeah, so that u of n minus 3 should come along with this. So this is what is the summary. So you can write it this way. The first way also you can write, or this is smarter way of representing the signal. Understand? So it is represent the signal in this compact form. Fine. So this is also equally good, but this is maybe for learners. This is for learners, but you'll not lose marks. Okay, don't worry, you'll not lose marks if you write this, but this is for smart people. Okay, let's not say smart people. Smart has got different meaning now. Who's smart? Those who don't hard work, they're smart, and they'll do anything and everything to get the success. The smartness, the definition of smartness has changed now. It has got some negativity into it. Okay, so if you want to see it that way, it sounds that. Okay, so let's not get into it. So let's say that this is efficient way of representing the signal, the output rather, efficient way of representing the output. Fine. Okay, so this is how we do the problem. Something new that we have learned here is this. What? U of n minus 3 minus k is what we have learned newly. Okay, it's not new, rather. U of n minus k we had seen. So instead of u of n minus k, we saw u of n minus 3 minus k. U of n minus k was ranging from minus infinity to n, but this range is from minus infinity to n minus 3. That's it. Okay, and here one thing that you should not forget is when we write n minus 3 less than 0, we should not forget to write it is n less than 3. So in the summary, see here, we write it is n less than 3, n greater than or equal to 3. So we will not write n minus 3 less than 0 here when we are summarizing. Okay, so keep that in mind. Fine. So now let's go with another problem. Everybody just copy down this. Similar problem, very similar problem. Okay, but we have two exponentials here. Find problem number 6 maybe. Okay, compute the following convolution sum. Compute the following convolution sum. So what is that we'll be doing? So that is y of n equal to, they have given this to be beta power n u of n convolution sum alpha power n u of n. So these two signals you need to convolve or obtain the convolution sum for. So as we did in the previous problem, here also let's do this in the solution. First, let's call the first signal as x1 of n. Okay, so that is our beta power n u of n, and the second signal is what? Alpha power n u of n. So therefore, y of n would be x1 of n convolution x2 of n, and this equation would be k ranging from minus infinity to infinity. Okay, x1 of k, x2 of n minus k. Fine. So therefore, y of n looks like what? Therefore, y of n would look like summation k ranging from minus infinity to infinity, beta power k into u of k. Everybody understand? So this is beta power k u of k. Fine. What is the second signal now? In the second signal, it is x2 of n minus k. That means wherever n is there, that needs to be replaced by n minus k now. Fine. So it is alpha to the power n minus k into u of n minus k. Fine. Now, this alpha power n minus k can be split into two parts. One is alpha power n, another one is alpha power minus k. Everybody understand that point? So that is what is the thing that we need to do here. Fine. So first let's get this equation in proper form. So this is beta par k, let it be that way, u of k. So this can be written as alpha par n is one part, another part is what, 1 minus alpha to the power k. Why it is 1 minus alpha to the power k? Because it is alpha to the power minus k, right? Alpha to the power minus k is 1 by alpha to the power k. Is that understood now? Alpha to the power minus k is 1 by alpha to the power k. Fine. So it's u of n minus k at the end. Now, in this summation, which uh, part has got nothing to do within this summation, where the k ranges from minus infinity to infinity? Anybody? Which signal here can be taken outside the summation? Just see what has got nothing to do within this summation, because k is ranging from minus infinity to infinity. Serious? Alpha power n has nothing to do within this summation. So let's bring this alpha power n here and let's combine this beta power k and 1 by alpha power k. Both have got power k's. Okay, so I can write this particular signal as, or the summation as, okay, alpha power n I'll keep out. Fine, then it looks like summation k ranging from minus infinity to infinity, beta divided by alpha is what I want to write it as, okay, to the power k. Then you are left with u of k into u of n minus k. Understand? And one more thing that we again forgot to say here is beta is also less than 1 and alpha is also less than 1. Because if you don't understand the values of beta and alpha, so they are exponentials, right? We'll not be able to make out what this exponential is going to be. Understand that? Now, if that is the case, if beta is less than 1 and alpha is less than 1, fine. I can say beta by alpha is also less than 1. Understand that point? Okay. If I say beta is less than 1 and alpha is less than 1, then I can say that beta by alpha, okay, the ratio is also less than 1. Fine. So that one thing we shall remember. Now we need to sketch this. So this is a decaying exponential. Understand that? So again, this is a decaying exponential, mind you. Decaying exponential ranging from what, minus infinity to no, not minus, 0 to infinity. So who's this? What is he doing? He ranges from, it is 1 from minus infinity to n. So this signal is 1 from minus infinity to n. We have been seeing this, and this is decaying exponential from 0 to infinity as beta by alpha is less than 1. That's why it is decaying exponential, mind you. Fine. So we need to sketch this now. And this is our equation number 1. This y of n, what we've got now, is equation 1. Understand this? Now let's check. Or let's draw our sketch. Fine. So I've told you this is decaying exponential. Again and again, I'll not go in details of explaining how it looks like. Okay. Any decaying exponential or any exponential for that matter will have 1 at k equal to 0. Since it is decaying exponential and ranging from 0 to infinity, on the left hand side, you will not have any samples. So you'll have samples only on the right hand side. And since this is decaying exponential, the samples, the following samples would be, okay, decreasing in their amplitudes. So this is sufficient to say. You need not have to write the values of it. Fine. So who's this? He is beta by alpha to the power k into u of k. Stationary signal. He is moving, the n minus k is moving. So let's write the moving signal now. Okay. So the moving signal is this u of n minus k, again something that we've been seeing in almost all the problems except the previous one. 0 sample minus 1 sample minus 2 sample minus 3 sample 0 minus 1 minus 2 minus 3 sample, and it goes from, see here this dot tells that it is coming from minus infinity and goes and stands at n, not beyond that. Now can you do it yourself from here on? What happens? There are again two cases. One is no overlapping case and another one is overlapping case. Okay, so case one everybody. So case one is no overlapping case. Case one, let's not say no overlapping directly. Let's say when n is less than 0. Okay, no overlapping. No overlapping is happening. Understand that? So when no overlapping is happening, okay, y of n is 0 and y of n is 0 for n less than 0. So this is the first case. Understand that? Now, case 2, when there is overlapping, what is the range of overlapping? This case 2 rather. When n is greater than or equal to 0. See, when this n is greater than or equal to 0, let me write that, right? Let me write both the cases for you. Fine, so you'll have better understanding. So one is decaying exponential starting from 0. Fine. Another one is this signal which goes from minus infinity to n. So no overlap. Fine. That is when n is less than 0. Fine. Now what? Let's again take the standing signal, the stationary signal. Okay. It starts from 0 and goes till infinity. And this, if you take, now this person is going and handshaking with the players. So this is n. So what is the overlapping range? Overlapping range is 0 to n. Understand that? So this is for your reference, and you can even show this, not at all a problem. Okay, now let's go with this. Therefore, there is overlapping is what is understood when n is greater than or equal to, there is overlapping. Let's directly say overlapping range. So overlapping range is k ranging from what? 0 to n. So therefore, equation number 1 becomes y of n equal to, there is an alpha par n outside, then within the summation where k should now range from 0 to n because overlapping range is that, you have beta by alpha to the power k, and the other two unit step functions are 1. Understand this? Now, since this is again going from 0 to n, how would this look like? Therefore, y of n would look like alpha par n into 1 minus beta by alpha par n plus 1 divided by 1 minus beta by alpha. Okay, and this is for n greater than or equal to 0. Is that okay with you? So summarize it fast now. Summarize it fast, everybody. That is therefore summary. So I'll write the short form of the summary. Therefore, y of n is equal to alpha power n 1 minus beta by alpha to the power n plus 1 divided by 1 minus beta by alpha. Okay, and this much into u of n. So this is how we can summarize. U of n means it understands that y of n is 0 for n less than 0. So that is this. Y of n is 0 for n less than 0. And it is this for n greater than or equal to 0. And that is told by u of n. Fine. So this is what is the summary.